Okay, today we're going to work on ratios and proportions. Remember, you can always pause and rewind if we're going too fast. So we use ratios to compare numbers by division and multiplication. We need to learn about them because we can use them when we cook or when we want to compare numbers in relationship to one another. For example, a cake recipe calls for 2 cups of sugar, 3 cups of milk, and 5 cups of flour. Well, what if I want to know some ratios from this recipe? So let's go ahead and find the ratio of sugar to milk. Well, how do I do that? Well, we like to use a tool called Words First. So I'm going to look at the information again, I'm going to reread it, and I'm going to circle and underline important information. So on this one it says a cake recipe calls for 2 cups of sugar, so that's important, 2 cups of sugar, 3 cups of milk, and 5 cups of flour. Good, so I have my information circled and underlined. Now I'm going to look at the words first. So the question, very simple, it says ratio of sugar to milk. So that's exactly what I'm going to write it. I'm going to write it as a ratio. So I'm going to write sugar and as a ratio it's in fraction form, but it's also a ratio form, 2, and the fraction bar is read as the word 2, milk. And now we said equivalent or the same as, and we're going to look at our information. Ratios always have 2 numbers. So I know that one of these are not going to be used. Well, let's see, sugar needs to match with sugar. So here I have my sugar. I have the number 2. So of course I'll use the number 2. And it's 2 milk. So I just need the milk, and it's the number 3. So I'll write the number 3. And I'm pretty much done. I like to write it in all 3 forms. This again is the fraction form. It's read 2, 2, 3. And we also have the colon form. And it is also read 2, 2, 3. And then we have it in word form, which is 2, 2, 3. So for every 2 cups of sugar, this recipe has 3 cups of milk. And you see it's the same. So now I want you to go ahead and try and find the ratio of milk to flour. And go ahead and practice writing the ratio in all 3 forms, and I'll give you a second to work that. Alright, so let's go ahead and using the same tool we're going to use Words First. So in this example again we had milk, to flour, so we'll go back to our information. The cake recipe calls for, again I'm going to do all the important information, 2 cups of sugar, 3 cups of milk, and 5 cups of flour. Well, let's see what our ratio in words is looking for. Let's say it's milk. So here we have milk, and it says 3. So again we said it, milk goes with milk. And we have flour, and here's the flour. We have 5. Flour goes with flour. We're going to do all 3 forms. So next is the colon form. And then also in word form. So your answer should be similar. And remember to use the tool. So for every 3 cups of milk, this recipe has 5 cups of flour. So 3 to 5, 3 to 5, 3 to 5. Let's go ahead and work some actual problems now and see how we can apply this tool, the Words First tool, to actual ratio problems that you would see in school. Okay, we're going to do this one together. I'll go ahead and read it out loud first, and then we'll go back and we'll go ahead and underline keywords and information. It says Lisa has 90 baseball cards and 58 soccer cards. What is the ratio of baseball cards to soccer cards? So now I'm going to go back and I'll go ahead and underline keywords and information. Okay, well 90 of course looks important. So I'll circle and underline baseball cards. 58 soccer cards. What is the ratio? Ratio means there'll be two numbers of baseball cards to soccer cards. Alright, so working together, we're going to use words first. It's asking for the ratio of baseball cards to soccer cards. So I'm going to put baseball. To, and it's soccer cards. And again, I'm set at equal to. So let's go back to the information and see what it says. Well, it says that I have 90 baseball cards, so 90 goes with 90. Two, and let's look at my soccer. Well, it has 58. Alright, so normally I would be done, but I am noticing that this ratio is not in its simplest form. So I'm going to use a tool called another tool called a division ladder. And it looks something like this. I'm going to put both numbers, and it's important that you put the numbers in the division ladder the way you see them in the ratio. So since 90 is first, I'm going to put 90. And then 58. Now, I know that these two numbers share the number 2 as a common divisor because they are both even numbers. They both end in an even number. So 90 divided by 2 is 45. And 58 divided by 2 is going to be 2 and a 9. Now, I'm going to try and find a common divisor for both of these numbers. And after looking at it, I'm deciding that the only common divisor that they share is the number 1. So that's going to be my final ratio. I'm going to take it back out just the way I put it in. So 45 was first. So 45 on the top. And 29 is on the bottom. Another good strategy is to go ahead and label these numbers. So 90 was baseball. I'll just put a B. 58 was soccer, so I'll put an S. And that way there's no confusion. I have 45 baseball. Baseball has to go with baseball. And 29 soccer. Soccer has to go with soccer. So I'll go ahead and let you look at the second one. And I'll let you go ahead and work it out by yourselves. And I'll give you a minute or two. Alright, so let's go and see the answer to this problem. I'm going to go ahead and read it. It says Lisa has 144 football cards and 64 basketball cards. What is the ratio of football cards to basketball cards? So again, I'm going to underline circle for information. This says 144 football cards and 64 basketball cards. What is the ratio of football cards to basketball cards? So again, words first. I have football. And then I have basketball. And remember, I have to match them up. So football goes with football. I have 144 football. and I have 64 basketball. So again, I know I can simplify these numbers. I'm going to go ahead and use the division ladder. 144 was first, so I'll put 144, and I'm going to label them this time. Put F for football. And then basketball was 64, so I'll put 64 and basketball. We'll work through this fast. So I know they share 2 as a common divisor. That's going to be 72 and 32. Again, they both share 2 as a divisor because they're both even numbers. That's going to be 36 and 16. Again, 2 is a common divisor. They're both even. So that's going to be 18 and 8. And then 2 as a common divisor. That's going to be 9 and 4. These only share 1 as a common divisor, so I know I'm done. So again, I match them up. 9 goes with football. Football has to go with football. Sorry about that. So football with football, 9. And basketball with basketball, so that's going to be 4. And I'm going to write it in all 3 ways that I know to write it. So 9 to 4, 9 to 4, and 9 to 4. So for every 9 football cards he has, he will have 4 basketball cards. Okay, let's go ahead and work a different type of problem. We'll do this one together. It says Jimmy has 24 pencils and 8 pens. What is the ratio of pens to pencils? So let's go ahead and circle and underline. So this one says Jimmy has, change colors, 24, of course, important, pencils, and 8 pens. What is the ratio of pens to pencils? Now this is why it's important to put words first, because this one's trying to trick us. I don't know if you noticed, but it says pens to pencils, and the numbers are set up as pencils to pens. And then it also has the number 8 in word form. So again, just be careful of that when you're reading. So we're going to do the ratio. We're not going to look at this part. We're going to look at the question, because that's where we get our ratios, from the question. So it says the ratio of pens to pencils. And we have 8 pens. Remember, pens goes with pens. To 24 pencils. Now again, this is not in the simplest form, and I can use a division ladder to check that. 8 is first, so 8 goes in my division ladder first, and then 24. Now on this one, I know that they both share 8 as a common divisor, so that's going to 8 divided by 8 is 1. And 24 divided by 8 is going to be 3. I'm going to label it pens, and if this is pens, well, that has to be pencils. So pens goes with pens, and pencils with pencils. And I'm going to write all 3 forms. And I'll give you a minute to work this one out. It says Jimmy has 36 mechanical pencils. We'll read it together, and then you can write it down and underline and circle keywords. So it says Jimmy has 36 mechanical pencils and 4 erasers. What is the ratio of erasers to mechanical pencils? Okay, I'll give you a second. Alright, so I hope you paused it and tried to do this problem by yourself. I'm going to go ahead and circle the important information. 36 mechanical pencils. Again, it's kind of, this problem's trying to trick us because it says 4 and it's in word form, but it's the number 4. And remember, we get our ratio from the question, and the question says what is the ratio of erasers to mechanical pencils. So I hope that didn't trick you. So we're going to write the ratio in words first. It says erasers. I'm just going to put an E for erasers to mechanical pencils. So I'll put MP for mechanical pencils. And again, just set it equivalent. Erasers has to go with the erasers. So you see how these numbers are inverted compared to the question. So I'm going to put 4 to 36. And I'm going to check to see if it's in the simplest form. So 4 was first, so I'll put 4 here. I'll put MP. Oh, you see, I almost made a mistake. I'll put erasers, because erasers goes with erasers. And then 36 mechanical pencils. And again, I know that they share 2 as a common divisor, because they're both even numbers. That's going to be 2. It's going to be 18. And again, they also share 2. So it's going to be 1 and 9. And now I know that these numbers only share 1 as a divisor. So now I just need to input my information. Erasers goes with erasers. So that's 1 to 9. 1 to 9. And 1 to 9. So for every 4 erasers, this person has 36 mechanical pencils. For every 1 eraser, this person also has 9 mechanical pencils. So it's 4 to 36, 1 to 9, 1 to 9, and 1 to 9 is your final answer. Alright, let's try another problem. We'll do this one together. It says there are 3 students absent and 24 students present in Mr. Gilbert's science class. What is the ratio of students absent to the students enrolled in Mr. Gilbert's class? Now this one's a little bit different. This one is part to whole, which means it's the ratio is part of the students. In this case, it's part of the student body to the or the students in class compared to how many students are enrolled. The other problems we've been doing are they're called part to part. So let's see. This one says there are 3 students. 3 students absent and 24 students present. So if there's 3 students absent and 24 students present, then how many are there in total in Mr. Gilbert's class? Well, you would add 24 plus 3. That's going to give us 27 total. So let's look at the question, because remember, from the question is where we get the ratio. So here it says, what is the ratio of students absent to the students enrolled? And remember, enrolled means how many students are supposed to be in Mr. Gilbert's class. So how many people or how many students are supposed to be in there is 27, because that's the total. So it's absent. So there's 3 absent. Now let me do my words first. I'll put absent. 2, let's look at the question, absent 2 students enrolled. Alright, so let's look. There's 3 students absent, and there are 27 students enrolled. So we're going to put in our division ladder to make sure it's simplified. Put A for absent and E for enrolled. And both these numbers share a common divisor of 3. That's going to be 1 and 9. So 1 to 9, 1 to 9, and 1 to 9. So for every student that is present, for every student that is absent, 9 students are enrolled. So the ratio is 1 to 9, 1 to 9, 1 to 9. And I'll go ahead and give you a second to pause it so that you can do the second problem by yourself. Remember, this is part to whole, so it is part of the ratio compared to the total of whatever the object or problem is. Go ahead. Alright, so Angie has 10 rubber bracelets, or 10 green rubber bracelets, and 8 blue bracelets. Look at the question. Remember, that's where we'll get our ratio. What is the ratio of blue bracelets to the bracelets she has? So again, it's not blue, or it's not green to blue, or blue to green. The ratio is blue to bracelets that she has. So then we have to add them. We have 8 blue, 10 green. We add them, and that gives us 18 total. So now we look at the ratio again. We're going to set up our words. So we're going to put blue bracelets. I'm just going to put blue compared to the bracelets that she has. Well, how many bracelets does she have? Well, we added them. 8 plus 10 is 18. So I'm just going to put total, right? Because bracelets means total. 18 total. So again, we have to match them up. 8 goes with 8. And the total was 18. Alright, so now I'm going to check to make sure that it is simplified. I'm going to use my division ladder. I'm going to put blue, or B, and then a T here. It's 18. I know they share 2 as a divisor because both of the numbers are even. That's going to be 4 and 9. And the only divisor these two numbers share is the number 1. So I know I'm done. That's going to be 4 goes with blue. Blue has to match with blue. So that's 4. And then, of course, 9. 4 to 9. And 4 to 9. So for every 8 bracelets, this person has 18 total bracelets. For every 4 blue bracelets, this person has 9 total bracelets. So it's 4 to 9, 4 to 9, and 4 to 9. I'm going to do one more problem. And again, it's going to be slightly different. We'll work out the first one together. And then the second one, hopefully you give it a try yourself. If not, you can, of course, just follow along. So this one says, Alberto uses 55 teaspoons of soy sauce and 3 teaspoons of lemon juice. Let me make sure that's right. I think this should be actually just a single 5. So I'm going to cross it out because I made a mistake when I was writing it. This should read, Alberto uses 5 teaspoons of soy sauce and 3 teaspoons of lemon juice. How many teaspoons of soy sauce would he need if the lemon juice was increased to 9 teaspoons? Still use the words first, so let's go back and just go ahead and circle, underline our important information. So let's see, we're going to circle 5 teaspoons of soy sauce, 3 teaspoons of lemon juice, and let's look at the question. Remember, from the question we get a ratio. So it says, how many teaspoons of soy sauce would he need if the lemon juice was increased to 9? Well, remember, for ratio, we need 2 numbers, and I don't see 2 numbers here. How many? It's more of a question, so let's set it up how it is anyway. So it's teaspoons soy sauce, so I'll put soy, and it's 2 lemon juice, so I'll put lemon. Alright, let's match it. We don't have 2 numbers here in the question, so there's no way we can set it up from there, but we do have it in the first part of the problem. So I have 5 teaspoons of soy sauce, so 5 goes with 5, and 3 goes with 3. Now in the question it says, how many teaspoons of soy sauce would he need if the lemon juice was increased to 9 teaspoons? So I do know that the lemon juice was increased to 9. So I can use something called the property of 1 to find out what this number is going to be. So that's what the question is asking. It says if the lemon juice is increased to 9, what's the soy sauce increased to? So again, I can use the property of 1, and what I do is I ask myself, well, I know 3 times something is equal to 9. So I know that 3, of course, 3 times 3 is 9. And using the property of 1, whatever I do in the bottom, I have to do it to the top. So 5 times 3 is 15. So this one's a little different. Again, remember the question is not asking for a ratio, it's asking for an amount. So if the lemon juice was increased to 9 teaspoons, then he would have 15 teaspoons of soy sauce. So you can just write a little sentence saying he would have 15 teaspoons of soy sauce. Alright, so go ahead and copy the second problem. Make sure this is not in your way. It's not. Copy it down, work it out, and you can pause it. And here we go. Hopefully you paused it. Now we'll work on it together again. It says Albert works 7 hours and earns $84. How much does he earn if he works 21 hours? So again, I'm going to go back and circle. 7 hours earns 84. The question, how much does he earn? You see the question, it's a little bit different. It's not asking for a ratio. It's asking how much does he earn if he works 21 hours. So again, words first. You can do it earns to hours or hours to earns. So we'll go ahead and do hours to earns. Or you can put hours to money. Okay, so I have hours here. Again, it has to match with hours, so I have 7. And earns has to match, so I have 84. And over here I have hours, 21. And again, it's asking me how much does he earn, so that's what I'm looking for. So again, we're looking for the property of 1. So 7 times what equals 21? Well, I know that 7 times 3 equals 21. So we're going to have to use the property of 1. There it is. 3 over 3 is equivalent to 1. So now I have to do 84 times 3. Well, that's kind of hard, so I am going to work it out over here. 84 times 3. 3 times 4 is 12. Carry the 1. It's 24. That's 25. So should it be 252? So again, I have to write a little sentence. In 21 hours, he earns $252. Alright, see you end of the lesson, and hopefully this helped you. You can use these as examples for any of the work that you have in your class. Thanks.